Here I am back for part 2 of the Lichee Pi 4a system. I want to discuss some problems and some solutions for those problems that I do have a solution. First of all, system, when you install it and boot, comes up with the user logged into sipeed user account, which is okay, except the default for Debian and sipeed accounts are that they may execute a substitute user do as root without a password. You have to be very careful. That's probably a major security. Well, it is a major security flaw for some installations. You just can't walk up to a computer and do something as root without the password. And to show you how dangerous this can be, this is your system, and you left to go to a class, and your roommate comes over and sits down and says, "Oh, this is interesting. This is like Jurassic Park. This is Unix. I know this." So I'll do a substitute user. Then I'm going to do password, which is a command that allows you to change the password for your account. But it's also as root. You can change the password on anybody else's account. So let's just change the password on root. System doesn't come with a password. That may change, but until then, let's just set the password for root. You do this is if it's your system and it's first time, you want to make sure nobody can do something as root. Don't know if you know this, but there's one rule for root as a user on a Linux operating system. There are no rules. Whatever root says or asks the computer to do, the computer will do it if possible. It's almost at the password for root. So now it says, what's your new password? So you just put whatever your favorite password is. Then it wants you to retype it and make sure you didn't fail typing. And root now has a new password. And I'm the only one that knows it. Oh wait, there are 2 other users. Let's do the same thing. Whoops, I was typing 101. Well, more than typing 101. Let's change the password to Debian. I'll use the same one because I don't like to memorize a whole bunch of stuff. And then I'll change the password to this account. So now I own the system. Any account that's on there, the 3 of them, root, Debian, and sipeed, I have the password. Okay, so that's problem number 1. Number 2, I told you that I had network file system running on this system and on my main system so that I can access stuff to bring it over. Let's see what I have here. Let me remove this. I was playing with something. Okay, let me do a remove directory. Oh, so it's already mounted. So let me do an U-mount so that I can show you what I'm doing. All right, let's start over. Display file system. I got my root and my boot and some other miscellaneous stuff. I have a directory called JWST, and I'm going to use it to mount the file, my home directory from the other big system, the one that allows me 1 terabyte of disk space. Because if I do a free, let's see, here I only have 115 gigs, and 106 of it is available because I use 3.8 in the system plus whatever software I installed. So what I will do is I will do a substitute user do mount, and then I give the IP address of the other system. And when you set up NFS, you have to be very careful that you do not export the file system to the entire universe. That is possible. So that's my home directory on the other system. I'm going to mount it here to home directory here of this account to JWST directory. And then if I do a display file system in human format, the last line shows that on this system, home sipeed JWST directory, I have the file system from the other computer. It's 915 gigabytes in size, and I've used up almost 500 gigabytes of it. So let's go see what is available there. So I will do a CD to JWST, and it says permission denied. And you say, wait just a minute, I mounted it, I should have access to it. Well, that's not the way it works. If you do an ls minus LD for long display of a file and directories, and if there's a directory, I don't want to look at inside it. So if I do an ls, I have 3 directories in the home here for sipeed. I've got desktop, it's owned by me and it belongs to the group. I've got videos that belongs to me and it belongs to my group. But JWST belongs to Debian, belongs to the other account. Well, the reason for this is if you do an ID on Debian, Debian has a user ID of 1000. If I do my ID, user ID, I am 1001. The home directory on the other system belongs to Adams, and my user ID over there is 1000. So whenever you import a file system, all the file ownership and groups are using the IDs from the other system. So I'm not going to have access to that file system from this account. Now I can become root. Remember, I set the password to my new super duper secret password. Now remember, I'm root, so let's cd to home /sipeed/JWST, and voila, I've got access to everything. The ls command doesn't show color here, but I only want to do one thing. I want to copy the Fortran program I showed you yesterday, cp-r 02, and I want to copy it to home sipeed / and that's it. Now I'm going to exit out of here, so I'm now off the other system. And I'm back here. I've got a directory ls02. Let's see who owns it. And it's owned by root. Well, let me just change that. Because it's owned by root, I'm going to have to change the ownership as root. So since I am allowed to substitute user do without a password, I'll change owner recursively to sipeed. Sipeed, that's user and group for 02. Okay. Whoops. Should be a capital R. There are some commands that use lowercase r and some that use capital R. Now if I do an ls minus ld, you'll see that O2 is now owned by me. Now JWST, I could change it to the owner, user ID, and the group ID to sipeed, but it won't do me any good because when I get over there, the inodes, the information node for each file, has the user ID over there of 1000. But I don't care. I'm going to fix that in a minute. So there I go again. Now what I want to do is I don't want to use sipeed as my account anymore. I want to use Adams, and I want user ID 1000 so it'll match the other system. My recommendation for anybody that does distros is that you leave 1000 vacant. Do not assign a username to it so that when it becomes my system, I can add a user and I can assign the user 1000 if I want. All right. So now I want 1000, the user ID of 1000 to be Adams. How do I do that? Well, the simplest way for me to do that is just to delete the account altogether. So be very careful. This is this is advanced here, sort of. It's easy to do. What I'll do is I'll first delete Debian. So I do a sudo. So I want to become root. I'm going to use a user del, which you can obviously tell is to delete a user. I'm going to use a -r. So I'm going to delete the username, everything referenced to it in the password and the group files. I'm going to delete everything, and the person that I want to delete is Debian. Before I do that, let's do a ls ... Let's look at /home. So go up one level and list, and I see that Debian has a directory. That's their home directory, and I have my home directory. So let's go do that again. Substitute user, delete user. Now this is recursive, so and this is the case where it's a lowercase r. Good demo, Debian. So I go whop, and it says home directory is not owned by Debian. I did something to mess it up. So I'll do this. I'll do an scd ... and I'll do a sudo remove -r Debian. So this will remove the directory. Now in home, okay, in /home, there's only one home directory, and that's for the account that I'm using. Let me go back to my home directory. So I'm in home /sipeed. I want to add a user. So I have to do it as root. So sudo user add. Okay. Now I'm going to use my name, Adams. And I want to do this. Forgot what the -m. Let's just look at it. Info, user add. Man, user add. Create a new user. Let's see here. The flags are C, any text string that I want a short description of the account username, -d, create the home directory. There's a group. I can add myself to groups. That's a -g. What was -m? Oh, create the home directory. All right, start again. As root, user add, minus M minus U 1000. I'm going to use 1000 since I deleted it, and I'm going to put myself in the admin and the substitute user do group, and I'm going to name myself Adams. I can also go there and add my name. If I grep, look for the name Adams in the password file, I'll see that there I have Adams and got my user ID is 1000, group ID 1000, but there's no information about me. My home directory is /home/Adams, and the default here is that it's going to have you log in, and anytime you bring up a terminal window, you're going to run as the born shell. I want to use the born again shell, so I'm going to change that. And it's just the way the system's set up, and I'll come back in another lecture and change that. So let me just go as root vi/etc/password, go to the bottom, there I am, and then I'm going to change this to BA. Insert that. So now it's my shell for every terminal window that I bring up is going to be the born again shell. There was one other option on the user add. Let's add my name. Oh, it won't let me do that I should have done it when I did the user add. Well, I have to do it by hand, so let's do a sudo vi etc/password, and then I'll go in here and add Chuck Adams. So that's the name that'll show up for some commands later on. So now I have the Adams account set up. Let's go look at it. Whoops, typos galore today. LS, and you see there's Adams. I'll try to CD to Adams, do an LS, and there are no subdirectories. So another problem with Debian as distributed for this RISC-V system. In directory /user/scale, there is supposed to be a set of directories and startup run scripts for like .bash, RC, etc. that are not provided with the system. We will fix that in a more advanced discussion. Topic number 4. I showed you yesterday that I was having trouble with the cursor offset. If I go here and line the cursor up on the left-hand side, on my screen it's shown offset by 5 or 6 pixels. I noted when I looked at the video after making it that in the video it's not shown as an offset. It's shown in the proper position. So that means a couple of things, a couple of possibilities. Number one, because the simple screen recorder records from the frame buffer or the video buffer, actually from the display buffer in this case, at that point the image is correct. When it leaves the memory buffer and goes out to be converted into a format to displayed digitally on a monitor using an HDMI interface, something is wrong. Don't know. It's in the firmware, or there's a possibility there's an issue with my monitor. I doubt it, because I've never seen this on any other system. But I will take the Lichee Pi 4A and put it on another monitor to see if it's continued there. So that's a problem to be looked at. Now, one of the things that you will do is periodically you will do a apt update, and then you will do a apt upgrade to get new and improved versions of software that fix security fixes or fix problems like cursor offset or missing skeleton files, what have you. And sipeed here does an excellent job of doing the updates. And let's see if there's anything that's been done in the last couple of days. And there is. The following package was automatically installed and is no longer required. Oh, okay, so that's an update. So to remove it, you just do a sudo apt auto remove. And it's going to delete that, and that's okay. On this prompt, do you want to continue? It shows a capital Y and then a lowercase n. That means it's not case sensitive. You could do a lowercase y in it or an uppercase Y, that's okay. But you do not have to type in anything except a return. If you do a return, it says that the default is yes. So it goes and deletes it. And we're done. Now let me go back here and do a sudo apt upgrade. And it shows that the following packages have been kept back. Linux image 5.10.113-LPi4A. Now the reason that it's being held back is I did an update, and then I did an upgrade with everything. And when I did a reboot, the system would not come back. So I went, reinstalled the system on the eMMC memory. All right. And by the way, I looked it up. That's a extended memory, whatever it is. It's effectively a solid state memory thing that we're using as a solid state drive. And it took me 2 passes, and I found out which module, and it's this one that was causing the problem. To prevent, now I wanted to upgrade everything else. The way you do that is you do a sudo, there's an apt mark, and you can do a hold, which says do not install the following. And you type in the module or modules that are giving you trouble that you don't want to mess with. And if I do a return here, it would, and it says it's already set on hold, so no harm. Number 2, and I'm going to have to go and show you something else. I'm going to pause this recording because I need to download a photograph. Stand by. Now I've gone and inserted the memory card from the camera, and it shows up here it's mounted. So let me double click on it. And there's an image. So Well, let me just display it here. Goes and reads it in. It's a 7 meg image. Whoops. Oh, it brought up GIMP. That's a new image manipulation program. That's your Photoshop. I didn't need to bring this up. I could have used the Gwen view, but this is all right. First time to do this, it goes and inputs a bunch of plugins. Should I stop this or just let's be patient? Or not. Oh, come on. Image is being read in for display, and voila, there it is. Remember I showed you yesterday that I put the heat sink that was provided by sipeed, and that it wasn't working very well in my opinion, and I had purchased these little heat sinks. So I installed 3 of them, 2 on the memory modules here and here, and then this is the TH 5210, 52, yeah. This is the RISC processor, and this size exactly fit the chip, and these thermal pads, adhesive pads are thin, and they seem to be pretty efficient. So let me kill that off, kill that off, kill that off, and let's see if I got B top to look at the temperature. And the temperature is at 81. That's because I was running GIMP, plus I've got the recorder and everything. But on idle, the temperature is running around 52 degrees or something. And that's working pretty good. Wonder what the temperature would have been with, why am I running 4? Well, let's look at what's running. Something's eating up the system, and it's not this. Do a process minus A. PS, well, I don't see anything that, I guess just the simple screen recorders taking a lot of compute power for some reason. One other program top. Yeah, simple screen recorders using 3 processors. 4. When this load average here is at 5, let me get up there, at 5.44, that means I'm using 5.3 processors, but I only got 4. So there's going to be a lot of paging going on, and a lot of power being consumed by the processors. Let's not worry about that now, but that's what's going on. So there are the heat sinks. Let's see if I own O2. Yes, we go to O2. Now remember I showed you this program, RTO2.f, which is the first Fortran program I ever wrote, and I ran a benchmark on it. Let me see if I've got it set up right. There's some numbers, okay. This is, I'm solving 720 simultaneous nonlinear integral differential equations using a modified Adams Moulton Bashforth predictor corrector equation solver, and this is my step size. So I've got this thing set up. Let me see if I did. Yep, everything's okay. Now, I said yesterday I wouldn't show you the Fortran compile line because it was too complicated. Well, I got to show it to you because I forgot something. Fortran. Now, I'm going to have to go do an option no automatic. And what this does is this says, whoops. This says do not dynamically allocate memory to variables and then deallocate or free up the memory when you leave a subroutine or a function. The old Fortran on the IBM 3650 back in the 60s, remember this is the start of availability of computers to everybody. They weren't all that fancy then. And I also want to do a standard equal legacy because the language has changed from Fortran 4 to Fortran 77, Fortran 88, 92, whatever. There's probably a 2000 something, whatever. I want to compile R2.F. Now, I've got an A.out. I'm going to time, let's do this again, time ./A.out with the input file 001. And remember it took, what did it take, about a second? And this one shows that the time is 0.984 seconds. Time variation will be dependent upon whatever else is going on in the system. Now, let's go back to here and let's do an optimization. Let's go optimization level 1. So this will do whatever it can to speed up the runtime for the program by optimizing structures and using all kinds of things to fine-tune the code. So let's do it again. Time. Now it took 0.159 seconds. So it went from 1 second, 0.9, whatever it was, to 0.159. So what is that, a factor of 6? Let's see if we can get a little more. Now the next optimization level is 2. Compile. Okay, I want to time it again, so I'll say bang time, which says go back and rerun the last time I did a time. Now my time's down to 0.094, so that's a factor of 10 in optimization. Now remember, this program took over 3 hours on an IBM 3650 in 1966. So for now, and that system, you could lease it for $113,000 a month, and you only got 512K, that's kilobytes, of main memory. So you had to be very, very careful. We spent a lot of time writing programs that would run in a small amount of memory and try to get them as going as fast as possible, because users paid for computer time at a rate of, I think in 66 is around $440 an hour. In 1976 on an MDAL 470 V6, computer time cost $650 an hour. Now it runs 3 times faster, but it's still expensive. I don't know how much time I've taken up here on this video. The reason I show you this is if you're a student in physics or sciences or even in computing science, there's a possibility somebody asks you, or you're interested in something, you go out on the web and you find a piece of code that was written way back when, and you want to compile it and run it. And this is how you do it. you have any questions, just send me a personal correspondence via the channel, or you've got my email if you've been through the video yesterday. Use the one here, 1G. See this? Oh, this thing's not even well. This is not even up to date. That's good. I don't want you to know where I live. Okay. And here shows you how to compile it. It used to be labeled RTO1, but it's because it was the first program. But I rewrote it in C, and I'll demonstrate that in another video. So there's my email address if you see something that I screwed up or you're interested in something else. But my time is pretty valuable because I'm doing these videos and it takes time. That's the lecture for today. Purpose was to show you some problems and how to solve them, make you a little more comfortable with using the system. Again, I'm excited about this system because compared to what I was using when I first started out, it's just night and day. Even though I have a $2,000 system that runs at 5.5 gigahertz, I enjoy using something that's cheap and available to everybody and won't break your budget. Thank you for your time. Hope you appreciate these, and I will come along and do some more. I'm going back to the Lichee Pi 5 Plus videos. Also, since you have my email address, if you know of a cheaper or a faster RISC-V system, let me know, and I may be interested in purchasing it to experiment with it. I like to take a brand new computer and for the first week or two exercise it, find out what it's capable of, and find out the problems before I start doing serious or semi-serious work on it. Again, thank you for your time, and until next time, just crank them up and heat them up.